So extraction of the metal, how we extract the metal. Yes, the last session we discussed the extraction of aluminum, and today we'll discuss the extraction of zinc and iron. So if you want to extract the zinc, what is the ore of the zinc? The natural occurring compound of a zinc, that is zinc sulfide, which is also known as zinc blend. Like ore of aluminum is a bauxite, whereas ore of the zinc is zinc blend, which is mostly zinc sulfide. So first what we do, first we crush this zinc sulfide, like we have the large pieces of zinc sulfide, and we crush it and break down into a smaller pieces. And then we put into water in which we blow the air. So first the zinc sulfide, the ore of the zinc, which is also containing other impurity, we crush and we add this to water and we blow the air. So as a result, when we blow the air, what it causes? It causes the rock particles to sink, whereas the ore of the zinc ore will be there at the top. And then we skimmed off this zinc sulfide, that is skimmed off from the top layer. Now after that, the zinc sulfide which we obtain here, we dry that, and first thing, the zinc sulfide is converted into zinc oxide. So because it is easy to remove the metal from their oxides as compared to sulfide. So first, zinc sulfide is heated in the presence of oxygen or air. It will form zinc oxide and sulfur dioxide. Then this zinc oxide, which is mixed with a coke or a carbon. So as a result, when it is mixed with a carbon, what will happen? Carbon will displace this zinc. As carbon is more reactive, so zinc will be separate and will form carbon monoxide. So the zinc metal produced cool down and the carbon monoxide is burned, which give out heat energy and reduces the cost of extraction. So this is how we extract the zinc from its oxide. This is a furnace. This is a furnace which we use for extraction of a zinc. This is how the furnace will look like. So at A, what we do at A, there is a mixture of zinc and carbon is added. So what we do, and basically it's not a pure zinc, it is a ore of the zinc, which is zinc sulfide. So from the top we add zinc sulfide and we add carbon. And at the bottom of the furnace, we put air, a blow air or hot air is there. So hot air always rise up. Most of the air contain nitrogen and then 21% oxygen is there. So when the air rises up and this zinc sulfide is coming down, so first what will happen? The zinc sulfide, which is known as the ore of the zinc. So first reaction which occur, that zinc sulfide is there. It reacted with oxygen which is coming from the bottom. It forms zinc oxide plus sulfur dioxide. Then this zinc sulfide which is produced reacted with the carbon which we are adding from the top. So zinc sulfide plus carbon, it will form zinc plus carbon monoxide. Because the temperature of the furnace is so high that the zinc is not in a solid form, zinc is in a vapor form. So zinc, because the temperature of the furnace is so high, so zinc will be in a vapor form, like dotted lines are representing zinc. And when zinc is coming out, the zinc cool down. When the zinc cool down, it will convert into, first, a molten zinc is there. Like because zinc condenses, here we have a liquid zinc and then we remove it out from the furnace. So this is how the zinc is extracted from its ore which is known as zinc sulfide, also known as zinc blende. So you have to learn the technique how zinc is extracted, the whole procedure. Then what are the uses of the zinc? Zinc can be used as galvanizing. What is the meaning of galvanizing? Because what happens if you have a piece of iron, iron has a tendency to react with oxygen and water vapor in the atmosphere. So we have like iron is there in the atmosphere, we have water vapor and oxygen as well. So this water vapor and oxygen can react with iron, and when it react with iron, it causes a rusting of the iron. And what is the effect of the rusting of the iron? When iron rust, its strength decreases, because when it turn into rust or iron rust, it become weak, like its strength reduces. So how we can prevent the iron from the rusting? If you want to stop this iron from rusting, and so for that we can coat this iron with a more reactive metal which is known as zinc here. Like example, this is about the rusting of iron. As you can see, there's a piece of iron. When we leave it for some time, you can find that these red spots are there on the piece of iron. These red spots are there. What are these red spots? These are actually the rust. So iron structure, when they are exposed to the atmosphere, they rust. And what is the effect of this rust? It reduces strength of iron. It will not will remain strong. It will become weak. So to overcome this, to protect the iron from rusting, what we can do, we can have the layer of, or we can just place a zinc on iron. Like this is a piece of iron, and we can coat this iron with a layer of a zinc, and not necessarily completely coated, like we can have a small amount of zinc on this iron. Now what will happen when we check the reactivity series? We have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So when we check the reactivity series, you can clearly see that zinc is more reactive than iron. So what will happen? If oxygen and water vapor are there in the atmosphere, it won't react with iron, because iron is less reactive. So both of them will react with oxygen. So we can call this as a zinc sacrifice for iron. So if zinc is the sacrifice for iron, this is also known as sacrificial protection. So by placing or coating the layer of zinc on the surface of iron, we can protect the iron from rusting. And this technique, what we call that as galvanizing. So galvanizing is basically coating the iron with a zinc so that the iron will not rust, and iron is protected because zinc is more reactive. So we can use zinc. This is one of use of the zinc. It can be used as a galvanizing. And the second use of a zinc, it is used in an alloy. Zinc is a mixture as a brass, which is a mixture of zinc and copper. So when zinc and copper mix with each other, it will mixture of the metal. We call that as alloy. So brass is basically an alloy of copper and zinc, which can be used for different electrical components as well. We use, and it is harder compared to pure metals. Is it clear the two uses of zinc? One is galvanizing, another one is using an alloy of a zinc, which is a mixture of copper and zinc. So now some questions related to zinc, as we already discussed the extraction of a zinc. So the first question is, zinc is extracted from its ore, which is called a zinc blende. Zinc blende is basically zinc sulfide, which contain zinc sulfide ZNS. Zinc sulfide is converted into zinc oxide. Describe how zinc sulfide is converted into zinc oxide. So how to convert zinc sulfide into zinc oxide? So what we can do, we can heat with air, or you can say oxygen, or you can also say roast in air. Because when zinc sulfide react with oxygen, it gives zinc oxide. What is the chemical equation for this? So it should be balanced, and you have to learn this. When you have zinc sulfide, it reacted with oxygen. So because oxygen is a non-metal, whenever non-metal is there, it will displace the second part of a compound. So it will displace this sulfur and it will form zinc oxide. But why formula of zinc oxide is ZnO, not ZnO2? Because whenever you're writing a formula, you should be correct for use the correct valencies. Zinc is +2 and oxygen is -2. When we simplify the valency, so 1 and 1, so zinc oxide will be ZnO. Plus, because sulfur is removed, so it will produce sulfur dioxide. And then we have to write a balance equation. How to balance this equation? When we check, like example, zinc is there, sulfur is there, balance. But what about oxygen? We have 2 oxygen on the left and we have 3 oxygen on the right. So if we put, because we are already having more oxygen, so if we put 2 here, so zinc is 2, because what we did, we tried to make 4 oxygen. So zinc is 2 on the left hand side, zinc is 1, so we put 2, zinc is also balanced. But when we put 2, zinc is balanced, sulfur is not balanced, sulfur is 2 on the left hand side. So sulfur should be 2 on the right hand side, so we put 2, sulfur is also balanced. And what about oxygen? 2 multiplied by 2, 4, and plus 2, 6. So we need 6 oxygen on the left hand side, so we put 3, so oxygen is also balanced. But instead of balancing during the question, it is better you learn this equation, because this equation always remains same whenever you are having a question related to extraction of zinc. So there are certain equations you have to memorize so that you will not lose a mark. Then zinc oxide is reduced in the furnace. Name a substance that is added to the furnace to reduce the zinc oxide. So what substance is added? What we add? We add a carbon here, so we call that as coke. So coke is added, basically that's a carbon. Then the next part, how the pure zinc is removed from the furnace and collected. So if you see this process, how the pure zinc is collected here and it is removed. So first, when zinc is produced here, it is in a vapor form, and then it is, so zinc first vaporized. The reaction, when zinc oxide reacted with the coke, the carbon, it forms zinc metal and carbon monoxide. So this zinc metal, which is produced here in a solid state first, that because of the temperature, it is vaporized. It converts into vapor. So zinc gas is produced, and then when it is coming out, it is losing energy. So this zinc gas convert into zinc liquid. So how the zinc is removed from the furnace? First, it is vaporized or boiled, and then it is condensed. So that is the question. The last part, they ask how this zinc is removed from the furnace and collected. So first thing, what happened? The zinc is boiled. A solid zinc which is produced is boiled, and then at the top of furnace. And this furnace is known as the blast furnace, because when we supply heat energy and carry out this extraction, we call that as a blast furnace. Is it clear, this question about extraction of a zinc? Then another question related to extraction. So you will find a similar question and you will find the same answers as well. So in the question, zinc is extracted from an ore called zinc blende, which is zinc sulfide. The zinc sulfide in the ore is converted into zinc oxide. Describe how zinc oxide is made from zinc sulfide, like how we produce zinc oxide. So for the same answer is there, we roast in air or we heat with oxygen. Roast in air or heat with oxygen is having a same meaning. The second, write a chemical equation. Like what happened? So again, the same chemical equation, it won't change. So zinc sulfide was there, reacted with oxygen, it will form zinc oxide plus sulfur dioxide. And then we balance. So it is 2 here, 2 and then 3. So the equation is balanced. 1 mark is for writing a correct equation, 1 mark is for balancing. So same answer. Then the zinc oxide is converted into zinc. The zinc oxide and coke are fed into the furnace and air is blown at the bottom. The zinc is melted. The melting point of a zinc is 420 and the boiling is 907. The temperature of the furnace is 1000. Explain how zinc oxide is converted into zinc and then how heat is produced, an equation for all the reaction you describe. So first thing, how zinc oxide is produced, how zinc oxide is converted into zinc. So first thing, zinc oxide react with the coke. So when zinc oxide is there, which is reacting with the coke, this will produce. So zinc oxide reacted with coke, it will produce zinc metal plus carbon monoxide. The second, they are asking how heat is produced, how we produce a heat. The second thing, carbon monoxide burn to produce heat. So the second thing, the carbon monoxide which is there, or you can also mention coke react with oxygen to produce carbon monoxide. Both can be there because the coke or the carbon react with oxygen. Both are responsible for production of heat because burning is exothermic reaction. So whenever you burn something, the heat energy will be released. So the second reaction, the carbon reacted with oxygen to give carbon dioxide, or carbon monoxide which is produced reacted with more oxygen to give carbon dioxide. Or you can say carbon or coke react with oxygen to give carbon dioxide. Both are exothermic reaction. That's how they are producing a heat energy. Then equation for overall reaction you describe. And then how zinc is removed here, like we already did. Zinc oxide reacted with coke to form zinc. And then what happened to this zinc metal? How this zinc metal is removed? So first this zinc metal is vaporized or boiled and then it is condensed. But we don't have to write that. We just have to mention that zinc oxide reacted with coke to produce zinc and carbon monoxide, and that carbon monoxide or coke is burned to produce carbon dioxide and release the energy which cause the temperature of the furnace to increase. The next question, explain why zinc produced inside the furnace is a gas. So what is the reason why zinc is gas? As you can see in the question, they mention the melting point and the boiling point of a zinc. The melting point is 420 and the boiling point is 907. But what is the temperature of the furnace? It is 1000. So temperature of the furnace is more than the boiling point of the zinc. That is why zinc is in the form of gas. If the temperature of the furnace was between the melting and the boiling point, it will be liquid, and before the melting point, it will be solid. So why zinc produced here in a gaseous state? What is the reason for that? Because the temperature of the furnace is more than the boiling point of zinc. That's why it is in the gaseous state. Then state the name for a physical change for conversion of gaseous zinc into molten zinc. Like when a gas turned into liquid, what we call this? We call that as condensation. So conversion of the gas into liquid, we call that as condensation. Then rusting of a steel can be prevented by coating the steel with a layer of a zinc. So like example, if we have a steel, or steel is basically an alloy of iron, so it mainly contain iron. If we want to protect this, what we can do, we can coat it with a layer of a zinc. Like we can put a zinc layer on this. So in terms of electron transfer, why steel does not rust? Even if the layer of a zinc is scratched, like if the layer is slightly removed or scratched, then even in that case, zinc will not, like iron will not rust. So what will happen? In terms of electron transfer, electron always transfer from more reactive metal to less reactive metal. So when we check the reactivity, zinc is more reactive than iron. So what will be the transfer of electron? It is from zinc to iron. So how the marks are distributed for this question, and see the weightage, it's of 4 marks. So how you'll score the marks? Number one, zinc is more reactive than iron. That's one thing. So when you write zinc is more reactive than iron, you will score 1 mark. Then because we have to use electron transfer as well, like use the term electron. So zinc loses electron, or electron transfer from, because zinc is more reactive, so always, as we discuss even in a chemical cell, that electron always transfer from more reactive to less reactive. So electron transfer from zinc to iron. And whenever something lose electron, so we say zinc is oxidized, because oxidation is loss of electron. And the last thing we can mention, that zinc will react with oxygen and water instead of iron. So these are the points which you should include. Number one, zinc is more reactive than iron. As we know, the reactivity series, which we see zinc is higher above in reactivity. So if element is above in reactivity, it can lose electron easily, because it is a more reactive. So more reactive can lose electron easily. And that causes the electron to transfer towards the iron surface, and oxygen and water which are there in the atmosphere, they can react with zinc instead of iron. And whenever something lose electron, oxidation is a loss of electron, so we call zinc is oxidized. So zinc more reactive than iron will give you 1 mark. Zinc loses electron will give you second mark. Zinc will react with oxygen or water, that will give you the third mark. Or zinc is oxidized, that will give you the fourth mark. Is it clear, this question? Like how zinc prevent iron from rusting? So even this technique is not necessary to work with zinc. It can work with any more reactive than metal than iron. Like if I use a magnesium here, then this technique will also work. But because we are doing about zinc, That's why we are discussing only zinc. Then another way to extract the metal or to separate the metal, as we see the reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So when we check the position of the carbon is between aluminum and zinc. This is the position of carbon. And hydrogen is there between lead and copper. So it means carbon is more reactive. So if we use any more reactive metal than the other one, then the reaction can occur. Like example, if we can also reduce the metal oxide by hydrogen. So, but which metal oxides can be removed by hydrogen? Those which are below hydrogen, because hydrogen is more reactive. As we go down, the reactivity is decreasing. So if we have a copper oxide and we react with hydrogen, because hydrogen is more reactive, so it will displace the copper. So copper metal will be there and it will produce H2O or water. So we can use we can heat with hydrogen, the oxide of the metal with hydrogen, but the condition is that the metal should be less reactive than hydrogen. If we use a metal more reactive than hydrogen, then this reaction won't occur. Like example, if we were having zinc oxide and we try to react with hydrogen, then there will be no reaction. Why? Because hydrogen, when you check hydrogen and position of the zinc, zinc is more reactive, so hydrogen is not able to knock out this zinc. That's why there will be no reaction. We can also heat with carbon, and this can be done for the element which are more reactive than less reactive than carbon, sorry. So like zinc, iron, lead, we can heat it with carbon. Like if we have a lead oxide, as you can see, lead is below in reactivity. So if we have lead oxide and we heat it with carbon, so carbon is more reactive. Carbon can knock out this lead. As a result, it can form lead or carbon monoxide. This is also acceptable. Carbon dioxide can also be produced. Or we can also use a reducing agent which is called a carbon monoxide. Carbon monoxide is having a tendency to remove the oxygen from most of the compound. So carbon monoxide is a reducing agent. So copper oxide react with carbon monoxide. You can see first there is a copper oxide, then it becomes copper. So oxygen is removal of oxygen. Whenever substance removal of oxygen, we call this change as a reduction. So this change is reduction and we call that as an oxidizing agent. Same thing, carbon monoxide become carbon dioxide. There is an increase in oxygen or addition of oxygen. If there is an addition of oxygen, we call that change as oxidation. And for substance which oxidation happen, that is actually a reducing agent. So by heating with a carbon monoxide or carbon monoxide, which is a good reducing agent, it has a tendency to remove oxygen from the compound. So these are the techniques which we can use to extract the different metal by hydrogen, by carbon, and by carbon monoxide. Is it clear?